students, welcome back at your own channel Maths Mera, where we are here to discuss the academic part of our mathematics. Before starting with the academic parts, I would like to pull your attention towards a thought, and the thought of the day is: an arrow can only be shot by pulling it backward. Is it? Yes. If you want to hit an arrow, what you have to do? You have to pull it back, right? Directly you cannot throw. If we will throw it, it might not be achieving the target, and it won't be having that much force. Okay? So if you want to hit a target with an arrow, so you need to pull it back. How we can relate it with the today's conditions? Because today's conditions are what? We all are what? Like freeze. Okay, we have freeze. Everything is what? Stopped around us. We are not able to go out. We are not able to do many activities. We are not able to go in the crowd. So many of the things, many of the work are pending. Working in a school with the school work is easy. Working at home with the home atmosphere is also easy. But working at home, right, doing school's work with the home environment, somewhat it makes what? Difficult. Right? So right now it may be possible because of the COVID-19, we might be what? Slower in our activities, or many of us might be thinking now I have lost everything, but this is nothing in that way. It is what? We are being an good arrows, we are pulled by the God backward in back direction. Okay, what does it mean? As soon as the condition will be what? Normal, we will have to double our speed, and with that double speed we have to hit our target, we have to achieve our goals. So with the thought, let's go ahead in our daily activities. Now with the thought, let's go ahead in our academic parts. We are dealing with the chapter number 6, that is linear inequalities. Okay, now linear inequalities, before going ahead, just somewhat pull back to ourselves, that is recap. Okay, so in the previous video, what we have done, we have gone through the introduction part of chapter number 6, linear inequalities. Okay, in linear inequalities, what we have done in that video, all the components which we are going to deal with this chapter, we have gone through in short. Okay, now the difference between equation and inequality, or two algebraic expressions are compared with equal to sign, then it is known as equation. But if it is inequality, it means there is what? Chance of being what? Up and down. Okay, how it is? In two algebraic expression, if there is a sign of less than, greater than, less than or equal to, or greater than or equal to, that time we are calling those as inequalities. And since it is linear, it means the power of the variable should be 1. Okay, then how we have done the solution of the linear equation, like that only here also we are going to solve the linear inequalities with the same rules and the same principles. Is that okay? After that, the same equations or inequalities we are going to solve with the help of number line. The same inequalities we are going to present on number line, we are going to present it on graph. Then we are going to start with the linear inequalities in two variables, and both the variables, both the graphs we are going to present on graph. Then we are going ahead with the solution region. Now what is solution region? If we are presenting the point in our Cartesian coordinate system, then all the answers wherever they will come, that part is known as a solution region. There are two possibilities of inequalities, either it will be less than or greater than. So whenever it is less than or greater than, then we have to use the dotted line. Okay, and whenever it is what less than or equal to or greater than or equal to, that time we have to use the dark line. Now what is the purpose of dark line? It means the line and all the points which are on line are also the solution. Okay, and if it is dotted line, it means whatever the points are there on the line are not the solution. So this is all about the recap of the introduction part. Now let's go ahead with exercise number 6.1. The first sum, it is what all the full exercises what same, where we are going to solve. Okay, now instead of equal to sign, there is what the inequality sign, maybe less than, greater than, less than or equal to, or greater than or equal to. In that way only we have to solve. Okay, so the first sum is 24 x is less than 100. For number one is when x is natural and when x is what, integer. So this part we'll see later on, but first we'll solve it. How? Directly we can take that, divide both sides by 24. So that we are doing from long time, that is this one, and after that it can be given as 4 25s and 4 6s. Right or wrong? 4 25s and 4 6s. Beyond that also we can go if you want. That is 6 4s are 24, right? 6 4s are 24, then 0.61s are, and then 6 6s. That is 4.16. Okay, here. Therefore, x is less than 4.16. Now there are two cases when x is integer. Okay, therefore, when x is a natural number first, that time the answer for x is equal to what? It can be 1, it can be 2, it can be 3, it can be 4. Right? But when x is an integer, at that time what will happen? The x can take any negative value. Is that okay? And then it can be minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Can it go beyond 4.1, 4.2? No, because 4.1 and 4.2 are not integers. So we are going to stop at 4 itself. Okay. Now the sum number 2. That is what? Minus 12x greater than 30. Same thing, that is x is greater than 30 divided by minus 12. That is x is greater than 6 minus 2 and 6 5. Right? 6 5 are 30 and 6 2s are 12. Is that okay? And again same thing, that is what? Minus 2 into or 5 divided by 2 is what? Minus 2.5. Okay, and again same thing, that is what? When x is what? Natural. Okay, so when x is natural, so x can be more than 0, that is 1, 2, 3 and so on for all the values. Okay, and when it is integer, okay, so here x belongs to n. Okay, for x belongs to n, and here x is equal to, second point is what? Integer. Now when it will be what? Integer and greater than minus 2.5. So it will start with minus 2, minus 1 and 0 and so on. Okay, for x belongs to z, that is set of integer. Now sum number 3. That is 5x minus 3 is greater than, sorry, is less than 7. And for two values, that is natural and real. So that part we will do later on, but here it is 5x is less than 7 plus 3. So x is less than 7 plus 3, 10 upon 5. Therefore, what we are getting, x is less than 2. Now, for integer or for natural first, that is only 1 because it is less than 2, so 2 cannot come. Okay, for x belongs to natural number, and for what about x is real? X is real means what? Rational, irrational, all the numbers will come, but less than 2. Okay, so what we can do is, can we consider it as minus infinity, right, till 2 only, but we have to take care, we have to keep this bracket only. We cannot use the closed bracket, because if we will use closed bracket, then it will 2 will also be included. Okay, so here it is not. For x belongs to R. Okay, easy sums and simple sums. What is sum number 4? Same one, that is 3x plus 8 greater than 2. And for integer and real, so again same, 3x greater than 2 minus 8. Right? So x is greater than 2 minus 8 is what? Minus 6 upon 3. Therefore, what it becomes? It becomes x is greater than minus 2. Right? Now, x is greater than minus 2. For this, what are the solution sets? X is equal to what? Greater than minus 2. It means what? Minus 1 and so on. Integer. So, it is minus 1, 0, 1 and so on. Right? And here you can write down for x belongs to I, that is what? Integer, or x belongs to z, integer. Set of integer is what? Denoted by z. Right? Then here the same formula you can use, and in bracket, since it is what? Minus 1 is included, so you can write down minus 1 like this, and till infinity it will be positive. Right? Because x is greater than 1. Now for real number. So again same thing. Now it is greater than minus 2, but minus 2 is what? Not included. So it will be minus 2, and again it will be like this for x belongs to R. I hope so that you are enjoying the sum, that is 4x plus 3. Because whenever the sums are easy, that time we get somewhat interest to solve. Okay, so x is real. Now after this, everything for real number. Okay, when all the x are what? Real. So what we do here? 3, then this plus 7 will become minus 7, 6x minus 4x. Here minus 4 less than 2x. So minus 4 upon 2 is less than x. Therefore minus 2 is less than x, or x is greater than minus 2. So the same solution we have got like this only, but only the real part. So x is directly we can write down this only, that is minus 2 comma infinity for x belongs to R. The next sum is 3x minus 7. 3x minus 7 is greater than 5x minus 1. Okay, so the same sum, minus 7 plus 1 greater than, no sign will change. Okay, so minus 6 greater than 2x. So minus 6 upon 2 greater than x. Therefore minus 3 greater than x, or x is less than, right? The same thing, or x is less than minus 3. Easy to understand, that's all. Okay, so our x is what? Real number, and it is what? Less than minus 3. So x is equal to, here minus infinity it will be, but our x will not cross minus 3. So minus 3 also like this, closed interval, sorry, open interval. Okay, so for x belongs to R. Now the next sum, sum number 7. What is that? Sum number 7 is 3 into x minus 1 less than or equal to 2 into x minus 3. For x is real. So first what we will do, we will multiply and then we will go ahead. Okay. So 3x minus 3 less than or equal to 2x minus 6. Now the numbers together, variables together. So 3x minus 2x less than or equal to minus 6 plus 3. So directly we are getting x is less than or equal to minus 3. Okay. Now same answer, but what is changed? X is equal to minus infinity, but here 3 is included. So close interval. Okay. For x belongs to R. Some number next, that is 8. After that 3 2 minus x greater than or equal to 2 into 1 minus x. Again first multiply, 3 2s are 6 minus 3x greater than or equal to 2 minus 2x. So the numbers together, that is 6 minus 2 greater than or equal to minus 2x plus 3x, and here we are getting 4 greater than or equal to x, or x is less than or equal to 4. So what is your x? X is, it will be equal to 4 but less than 4. So here minus infinity to 4, but 4 is what in closed interval, or all x belongs to real number. Okay, and the next sum, that is what, sum number 9. For that, what it is? X plus 2, x plus 3 is less than 11. Now here the denominators are what? 1, 2 and 3 denominators are not same. So what we'll do will be making them same by using LCM. So the highest number is what? 3. Right? So we'll have to find out the LCM of 3, 2 and 1. It is what? 3 2s are 6. Okay. So this part multiplied by 6 upon 6. So it will become 6x upon 6. This part 2 into 3, 6. So 3x upon 6. And this part is what? 3 2s are 6. So plus 2x upon 6 less than 11. Now 6x plus 3x plus 2x, that is what? 5 and 6 what? 11x. 11x is less than 11 into 6. So x is less than 11 into 6 upon again 11. This 11 will cancel. X is less than 6. Okay. So therefore your x is, it is what? Again minus infinity to 6, but here it is what? Open interval, because it is less than. Okay. For all x belongs to real number. Now the sum number 10. What is sum number 10? That is x by 3. Sum number 10 is what? X by 3 greater than x by 2 plus 1. Okay. So again first simplify it, x by 3, x plus 2 upon 2, because 2 1s are 2. Then this 2 will come here. So 2 into x is 2x, greater than this 3 will multiply this numerator. So 3 into x, 3x, 3 2s are 6. And then what it is? It will be minus 6 greater than 6x minus 2x. Therefore what? Minus 6 greater than x, or our x is less than minus 6. To easily understand it, that's why what? X is equal to minus infinity, but since it is only less than, so minus 6 with open interval. Therefore for x belongs to R. Sum number 11. That is same thing we can try. Yes, we can. So the numbers and numbers. So this 3 will bring it here. That is 3 3s are 9 first, then x minus 2. Less than or equal to this 5 will bring there. So it is 25, 2 minus x. Now multiply. That is 9 into x, 9x minus 18 less than or equal to 25 2s are 50 minus 25x. Okay. Now the numbers together. That is say 9x plus 25x less than or equal to 50 plus 18. So 25 plus 9 is 34x less than or equal to, here only we do less than or equal to 50 plus 18, that is 68. So x is less than or equal to 68 upon 34. So x is less than or equal to positive 2. So the solution, therefore x is equal to, what it will be, less than or equal to 2, but it is real, so minus infinitive 2 is included for x belongs to R. Sum number 12. What does it say? Somewhat calculation is increased, nothing else. So it will be first 1 by 2 into 3x, 5 4s are 20 upon 5 greater than 1 by 3x. Can we do it here in this way? Yeah, we will do. Okay, x minus 6. Or here also what we can do is, this 2 we will take here, this 3 we will take here, so that the fraction part will go. So 3 into 3x plus 20 upon 5 greater than or equal to 2 into x minus 6. Therefore 3 3s are 9x plus 3 into 20. Okay, that is equal to 60. Upon this 5 will be there, but what we are doing, we are taking this 5 also here, that is 2 into 5. Here it will 2 into 5 is what, 10 x minus 6. So therefore it will be 9x plus 60 greater than 10x minus 60. Okay, so what we can do, this 60 plus 60 greater than or equal to 10x minus 9x. This will come here. Okay, so 120 is greater than or equal to x. Okay, or the same thing we can write, x is less than or equal to 120. Right? Since our x is real, so it can start with minus infinitive. It will include 120 also, so it will be a square bracket for x belongs to R. That is what real part. So these are what the first 12 sum. Here we'll take a halt, right? And simple recap of this is what we have solved the 12 different sums where we were solving the inequalities. The inequalities were less than, greater than, less than or equal to, greater than or equal to. Where we have used the simple rule when we can add, we can subtract, we can multiply or we can divide both the sides of the inequality with the same number. So it will not change the result. Okay, so this is what a kind of recap of this first 12 sums. Hopefully you have understood. Now the thing is what? Simultaneously you go on writing so that you won't have a burden. Right? So here only we are going to take a halt, and very soon we will meet again in our next video at your own channel Maths Mela with the continuation of exercise number 6.1. Till that time, be happy, be at home, and of course, be safe. Thank you.